All right, so before we start this lesson, at the end of the notes under where it says homework, I'm actually going to put the steps out that we're going to follow because that's something that you can use throughout any of these questions. So again, we're going to write out the steps first. Okay, and there are 6 of them. So step number 1, you have to have a good understanding of graphing because what you have to do is you have to graph the functions. Now what we're going to be learning about in these last few weeks is we're going to be learning about area between 2 curves and then rotating with volume between 2 curves. So again, it's important to understand graphing linear functions, graphing quadratic functions, sometimes trig functions, potentially cubic functions, but you might just want to do a little recap on graphing, especially if those types of questions come up on any of the worksheets that I give you. So step 1, you want to graph the functions on the same graph. So on the same graph. Number 2, what you want to do is you want to identify the region you're finding the area of. You find the area of. Now, typically what that's going to be, it's going to be the region between the 2 functions. Number 3, you have to find the parameters. Not always, but a bunch of times you do have to find the parameters. So what we mean by parameters is you are finding the points of intersection where the 2 functions cross each other. Step number 4, then we're going to set up our equation, and we'll learn how to do that when we get to the beginning of these notes. Number 5 is we are still on integration, so we have to integrate. And in fact, maybe where it says set up equation, I'm going to also write in simplify, which means if there's any like terms, you want to simplify those. And then after you integrate for 6, your final answer, it should be a simplified fraction, no decimals. So a simplified fraction, never negative, and given that we're talking about area, you also need units. So, and need units. Now, given that we're talking about area, it's going to be units squared. So you can write u squared for those. All right, so those are the 6 steps that we're going to follow when we go about these. I'm going to give you 3 examples in the notes, and then we'll start working on, you guys will have a chance to work on some of the book work. All right, so if we go all the way back to the beginning now, it's asking us to get the area. So if it's asking us to get the area, that's the area between 2 curves. So we're going to consider 2 functions that are continuous on the closed interval from a to b, and where one of the functions, say g of x, is less than the f of x function for all x in the closed interval from a to b. Okay, the formula that we're going to use is this guy right here. So area equals our parameters. Many times are going to be vertical lines, but they also could be the points of intersection that you might have to find. So in A and B, that's where they would come from. And in regards to now it's f of x minus g of x, how you determine that, what I always like to do is, first of all, again, the graphing is crucial because you need to know what the graphs look like. But another way of looking at it, f of x is the top function, and g of x is the bottom function, meaning one of them is going to be above the other one when you look at the graph. All right, so let's try one of these out. And then I'm going to make a second video with the other 2 examples. All right, so it says find the area of the region bounded by the graphs. So function 1, function 2, and then it tells us x equals 0 and x equals 1. So we're going to graph it first, and I'm going to graph it over here. Okay, well, y equals x squared plus 2, that is a parabola. That has a y-intercept of 2. And it's a positive x squared, so it opens up. All right, y equals negative x has a y-intercept of 0 and a slope of negative 1. So we're going to go down 1 to the right 1, down 1 to the right 1. and you're going to make a line. Now, what you find most of the time, I would say, much of the time, is that those two functions are actually going to cross each other and they're going to create a closed region. We don't have that here, but that's where these two bits of information come from. So you have two lines, x equals 0 and x equals 1. So these are two vertical lines. So x equals 0 is right here, and x equals 1 is right here, which with those two lines, that has now closed off our region, and this green region in the middle is what we are finding the area of. That is ultimately our goal. Now, we can't use formulas like we do in geometry for a triangle, a trapezoid, because all of these are curved edges. So this is where the integration comes in. Okay, so if we look at this, we have to first of all decide, okay, which function is above the other function? So if we look at the green shaded region, just that region alone, the parabola is above the line, which means that f of x would be up here and g of x would be down here. We see our x parameters here are going from 0 to 1. And now we have everything that we need to create our formula. So let's write the general one out first. So area equals, we're going from a to b, and we have f of x minus g of x dx. All right, well, a to b, those are our parameters. Those are our x parameters, so we're going from 0 to 1. F of x, we said, was the parabola. So that's x squared plus 2 minus g of x is the line, minus negative x dx. We want to simplify before we even focus on the integration, so I'm going to distribute that negative and get rid of these parentheses. So x squared plus 2 plus x dx. At this point, now we can actually integrate. So we get x to the third over 3 plus 2x plus x squared over 2. And we are evaluating that from 0 to 1. So we make two parentheses, one for the 1 and one for the 0. When we sub in the 1, everywhere there's an x, you're going to put a 1 in. And for 0, first term 0, second term 0, third term 0. So that whole part is just going to go away. So if we keep simplifying, 1 to the third over 3 is 1/3. 2 and 1 make 2. 1 squared over 2 is 1/2. Now keep in mind, the last step said they have to be left in simplest fraction form, which means you're going to have to get common denominators. And a common denominator between 3 and 2 is going to be 6, which means we have to convert all of these fractions to have a common denominator of 6. So 1/3 would be 2/6, 2 would be 12/6, 1/2 would be 3/6. 2/6 plus 12/6 plus 3/6 is going to get you 17/6. And then you have your units squared on there.